All right, so hopefully you, got to take in those different spring behaviors and they matched up with your intuition from when you did the introduction to Project 2 in class. You're going to get to play around more with this when you actually work on Project 2. But for now, what I'd like to do is just take a couple minutes to kind of give you, in one place, the rules for unusual roots. And so really what this is sort of way back when we introduced the steps for this method, I said there was this like 6-star where maybe your solutions are going to look different. So this is just going to be one place where you have all those rules right in like a convenient reference point for your notes. So I'll put a little star here, and it's just going to collect those same points that we talked about earlier. So first one was for repeated roots. So if root m is repeated p times, we're going to use solutions e to the mx, x e to the mx, and keep going until we've collected p of these functions, or x to the p minus 1th power, since you start with x to the 0 right there, e to the mx. And so, for example, well, actually, I think I can fit it right here. For example, if you have m equal to 4 3 times, so like m minus, or m plus, nope, it's m minus 4. I'll just write that, m minus 4 cubed. That's m equals 4 3 times. That would give you e, m minus 4 3 times would give you e to the 4x, x e to the 4x, and x squared e to the 4x. You have 1, 2, 3 of them, or the highest power is 1 minus however many times your root was actually repeated. The second example we talked about is if you have complex roots. So if you have complex m equal to alpha plus or minus, kind of got dragged out, alpha plus or minus I beta, we're going to use solutions e to the alpha x cosine beta x and e to the alpha x sine beta x. And so if alpha is 0, you just have the cosines and sines left. But if you have something like m plus or minus, if you have something like 2 plus or minus 3i, that's going to take you to e to the 2x cosine 3x and e to the 2x sine 3x. If you have just plus or minus 3i, that's going to give you cosine 3x and sine 3x. And then the last one I actually haven't given you yet, and it's going to be a combination of these two things. So if you have repeated complex roots, you just combine the two rules. And you can do it however many times you have to. So we'll do it again p times. We're going to use e to the alpha x cosine beta x, x e to the alpha x cosine beta x, repeating all the way down to x to the p minus 1 e to the alpha x cosine beta x, and then the same for the sine. So e to the alpha x sine beta x, x e to the alpha x sine beta x, down to x to the p minus 1 e to the alpha x sine beta x. And so, for example, if you had oh shoot, m equal to 4 plus or minus 2I, and it's repeated maybe twice because it starts to take up a lot of space. That's going to give us, let's see, e to the 4x cosine 2x, x e to the 4x cosine 2x. So I was repeated twice. I've created two solutions of my cosine type, and then I just have to get my sine type. 4x sine 2x, x e to the 4x sine 2x. And so it just combines with the like two different rules for that third type, the way you would expect, hopefully. So you want to have like your method, I think, for easy reference, but especially to have these rules for easy reference, just to know what to do when they pop up. Our last video is going to be our conclusion with your practice problems, so move on to that whenever you're ready.